In this video, we're going to look at finding solutions of trigonometric equations. And the first example is solve the following trigonometric equation. 3 sine theta equals 2. And we need to find the solutions between 0, for theta lying between 0 and 2 pi. So we'll take a look at the problem here on the writing pad. And so the problem we were given is 3 sine theta equals 2. And we're looking for the solutions for theta lying between 0 and 2 pi degrees. So we have a measure of radians there. So in order to solve this, we need to divide out by the 3. So we'll look at sine theta equals 2 over 3. So that's a positive value. Now we know in the first full cycle of sine, I'll just quickly sketch it here, that theta will be positive in quarter 1 and quarter 2. So we're looking at something like here and here. So we're looking for Q1 solution and Q2 solution. So the first sine inverse of 2 over 3 will give us our reference angle, which is the Q1 solution, is theta 1. And I'll just bring up the calculator. We'll have a look at that one. Now we were actually given the range in radians, so I think I'll switch the calculator to radians. So shift mode, radians is 4. And we're looking at sine inverse, shift sine 2 over 3, 2 over 3. And that gives us a measure in radians, and I'll round it to 0.73. So that's the measure in radians of theta 1. Theta 2, the second solution and the final solution we're looking for, is in Q2. So I need to say pi minus 0.73. And I'll just pull up the calculator again, and I'll go shift pi minus answer. Shift pi minus answer. So that gives me a measure in radians of 2.41. 2.41 rad. So that's both of the solutions, and that's the first problem. So we look at another type of example. In this example, we have to solve the following trigonometric equation. We've got cosine 2 theta plus 5 degrees equals minus 0.82. And we're looking for the solutions for theta between 0 and 360 degrees. Okay, so we'll take a look at this problem, and I'll just clear the page a bit. So this one, we were given cosine theta. We're given cosine 2 theta plus 5 degrees. And we're looking for all values of theta lying between 0 and 360 degrees. So when we have here, we've got cosine 2 theta. Now notice that should double the amount of solutions we're looking for. So in this case, I'm going to sub in x equals 2 theta plus 5 degrees. Now, because we're looking for 4 solutions for theta, I'm going to find 4 solutions for x. So we're going to find solutions for x between 0 and 720 degrees, so double the cycle. And then we find theta when we have 4 values of x. So the problem we were given was x. Just notice I didn't actually write the full problem. We have cosine x equals minus 0.82. Should have written that in up there. Okay, so we notice here cosine x is negative. So if we have a quick look at the cosine curve in its first cycle, cosine is negative q2 and q3. So we're looking first of all for solutions of x in q2 and q3. So we'll find a reference first, reference angle, cosine minus 1 of the positive value. And I'll get that up on the calculator. Now we need to, again, I'm just going to switch back this time to degrees 3, just to keep it consistent with the question. So we've got shift cosine, the positive value 0.82, and that will give me 34.9. I'll just make it 35 for ease. Is approximately equal to 34.9. I'll leave it at that. So this is a reference angle. The reference angle is in Q1. It's not a solution. So X1 we know is Q2, which is going to be 180 degrees minus the reference angle, 34.9. And that gives me 180 minus 34.9 is 145.1. The second x, which we're looking for, is in Q3, so it's 180 plus 34.9, and that gives me 214.9. To find a further two solutions in the next cycle, we take x3 is going to be my x1 plus 360 degrees plus a full cycle, and that gives me 300 and let me just check that one. I need to say 145.1 plus 360. 1.51 is 505 degrees. So that's my next solution for x. 505.1. And then my final solution for x4, is x2 plus a full cycle. So let's just bring that up. 214, I'll just go back to delete. Oops. 214.9 plus 360 gives me 574.9. So we have we've found 4 solutions for x, but what we are looking for is 4 solutions for theta. So remembering that x equals 2 theta plus 5, we can say theta equals x minus 5 all divided by 2. So we're going to take theta 1 equals, I'll bring up the calculator for that, so it's x1, I'll just go clear that, and x1 is 145.91, and I probably should be plus, no, it's going to be minus 5, just let me edit that, minus 5 over divided by 2. Okay, so that's correct, yeah. Which gives me the first, so we 70.05 is our first, 70.0.05. That's our first solution for theta. Theta 2, now I'll go back to the calculator and I'm just going to edit to put in x2 here. We have 214.9 equals, and we have 104.95 is our second solution for theta. Third solution for theta, theta 3. I'll go back and edit the calculator. So we're going to put in 505.1 and equals, we get 250.05. And then finally, the last solution, theta 4 equals and we'll just edit the last value to 574.9. And we have a final fourth solution of 284.95. So those are our solutions, 4 solutions for theta. Okay, so we'll just clear that down and we'll have one more example to look at, example 3. So solve the trigonometric equation tan squared theta equals 1 over 3. And we're looking for solutions between minus pi and pi. So the problem we were given is tan squared theta equals 1 over 3. So in order to look at this problem, we need to take the square root of both sides. So tan theta, you have to take into account that tan theta will give you both positive and negative 1 over root 3. So plus and minus 1 over root 3. So we're going to be looking for solutions between minus pi, theta, and pi. So we'll just take the positive value first. Tan theta equals 1 over root 3. So theta 1 equals tan minus 1, 1 over root 3. And I'll take up the calculator for this example. Now I need to go back to radians, so shift mode 4 for radians, shift tan inverse 1 over root 3. And I get the value of positive 1 over 6 pi. There's the cursor down here. So theta 1 is positive 1 over 6 pi. And that's one solution. Now, if we know tan, the period is pi. So if I add 1 whole pi to 1 over 6 pi, I will be outside of the range. That would be 7 over 6 pi. So we don't want to add a full pi, but we can find a second solution by subtracting pi from 1 over 6. So theta 2 would be 1 over 6 pi minus pi. And that gives me a negative 5 pi over 6. So this is another valid solution because it's inside the range. Now I have to also take into account the tan theta equals negative 1 over root 3. And if I look at tan minus 1 of negative 1 over root 3, negative 1 over root 3, I will get minus 1 over 6 pi. And to this, so that's theta 3. And the final solution, theta 4, I add a full pi to that. So minus 1 pi over 6 plus pi. And that will give me positive 5 pi over 6. Okay, so just to gather all our solutions together. So the solutions for theta will be negative 5 pi over 6, negative pi over 6, positive pi over 6, and positive 5 pi over 6. Okay, so that's it for this video. Thanks for watching.